I'm going to take a look at the Cannonball class today. I've downloaded this file folder, which has a Cannonball Java file in it. It looks like there's nothing there, and a tester maybe, and not much there either. So we're going to have to do pretty much everything for this. I'm going to go ahead and launch this as a BlueJ project there. So there are those two files. And let's take a look here at, let's take a look at this README file. I'm going to open this up and take a look and see what's here. It looks like this is yeah, this might be a markdown file. So let me take a look at this in VS Code. And here's the problem statement here. We're supposed to write this Cannonball class and then also a runner that will allow us to track what's happening with this Cannonball. And maybe we haven't used some of these things. This doesn't look like it's really a design activity. It's more of an implementation, but we're gonna have to try and figure out what's going on. It looks like there's a little bit of physics in here. We're playing around with tracking X and Y coordinates and velocity with X and Y components here. This looks like a little bit of a physics problem. So maybe before we get too far into this, I'll just double check here and make sure that we're good with the physics. So for projectile motion, go ahead and close this out here. For projectile motion, the way it works is you've got a few things that you can use to keep track of what's going on in a classic physics kind of problem. So one of the things, analysis, I should say. So one of the things that we'll be tracking, let's say there's a cannonball and we're firing it, and it's going to go flying up in the air and then it's going to plop down over here. So one of the things that we'll be tracking is the X and Y coordinates of that cannonball. And just to be clear, we're tracking those coordinates. We're not actually drawing a picture of a cannonball going. We're just modeling the cannonball. So there's going to be an X position. There's going to be a Y position. And another thing that we're going to be keeping track of is the X velocity. The X component of velocity as this thing moves across the screen in our model. And then a Y velocity. So it's got a Y component. Initially, it's going upwards in the Y direction. And then it reaches its apex at some point, and then it's going to fall back down. So we'll be keeping track of the velocity in the Y direction. And if you know anything about physics, you've probably studied this before, you know that there is no acceleration in the X direction, but there is an acceleration in the Y direction. And sometimes we call that the acceleration due to gravity. Sometimes we call it G. G is officially 9.8 meters per second squared. Oftentimes we make the negative down. So we could say that that acceleration was going to be negative 9.8 or something, negative G. So these are the variables that we're going to be using in our program as we try and figure out what's going on. The formulas for those, I'll just tell you right now, the final position as you're moving across here is equal to whatever the initial position was before, plus your velocity in the X direction times whatever time has passed between now and when you last checked. So if delta t is 1 second and you're traveling at 2 meters per second, your position is going to be 2 meters per second times 1 second, 2 meters farther to the right than you were before. Same thing's going on in the Y direction, except it's different because there's an acceleration in the Y direction. So we'll take our initial position and change it by, well, however fast we were traveling beforehand. We've got a delta t there. Plus then, and again, this is physics stuff, 1/2 times that acceleration downwards. So maybe we'll make that a negative 1/2, whatever the acceleration is, times delta t quantity squared. So yeah, we'll have to figure out what's going on there. That'll be interesting. What's happening with the X velocity? Well, the X velocity just remains constant the entire time. It's always equal to the same thing, so it doesn't change. But the Y velocity does change. The Y velocity has a final velocity that's equal to whatever its initial velocity was in the Y direction, plus the acceleration times that delta t. And since that acceleration is, again, in the downwards direction, maybe we'd be better off saying minus acceleration due to gravity. So we'll say minus gt. So sometimes the ball is going up, sometimes the ball is coming down, but we're going to have that minus change there happening. So these are the formulas that we're going to have to somehow include in our analysis as we're tracking what's going on. So that's the first thing. You just need to know about that physics there. And maybe we'll come back and take a look at those in a few minutes. But yeah, that's a jumping off point. So what are we supposed to do here? Let me take a look and see. Write a Cannonball class with the following methods: a constructor with initial X position and Y position. Y will probably be 0. Okay, well, let's make that constructor. First of all, I'm just going to tuck this down here. And let's make that constructor so we can figure out what's going on here. So this is the constructor for the Cannonball. I'll worry about the tester in a few minutes. All right, are you thinking about, you probably already have some ideas on what this might be. Yeah, I'll fill these in a little bit later on here. So, ooh, there's a point. I don't know anything about the point class. We're gonna have to take a look at that and see. So Cannonball, constructor, I need a constructor. Well, maybe before the constructor, I should be thinking about what variables I need to keep track of. They conveniently didn't mention that. So I'm just gonna write down to start those variables that were initially given to me. I think I'm going to go for doubles for these things because I could be at 2.5 meters or 3.5 meters. So I'll have a private double X value, which is the X coordinate of its position, and a private double Y value, and a private double V in the X direction, and a private double V in the Y direction. And is there anything else I'm going to need to keep track of? I guess that acceleration due to gravity, maybe I'll set that up. That's going to be a constant. The acceleration due to gravity doesn't change. So I'll set that as that can be a public value. Public final double, and that's going to be G. And now, should I make it a capital G? That seems a little weird to me. I'm just going to use G. And that's going to be equal to negative 9. I'm going to make it just 9.8 officially. Physics people know it's 9.8, and then we make it negative depending on the problem. So I'll make that a 9.8 there. That's not going to be changing. Cool. Yeah, and then let's make our constructor. So I'm going to construct a Cannonball. It's public Cannonball. What information do I need to put in there? I'm sending in initial X position and Y position. So double X, double Y, and let's do that then. This dot X is going to be equal to whatever the X is, and this dot Y is going to be equal to whatever the Y is. And I think, I guess, oh, geez, I should initialize Vx and Vy maybe. Yeah, I'm going to have to see. They haven't given me any information about this, so I'm just going to set those to 0 right now, and then we'll see what happens later on. And if I compile that, do I have any issues? No issues yet. I'm doing all right. Okay, what else? There's going to be a shoot method whose arguments are the initial angle alpha above the horizon and initial velocity v. Oh, good. So this is going to be where I actually get real values for v. So calling shoot computes the initial x and y velocities of the Cannonball. So good. Remember when we were looking at all this mess here, we had those initial values there. Get this out of the way. We had those initial values for x and y, and I need to initialize vx and vy. So when I shoot, apparently they're going to give me a velocity and an angle alpha there. And what I'm going to do is I'm going to take those two values and calculate my initial v in the x direction and my initial v in the y direction. And if you haven't done physics in a while, you may not remember that, but it looks like vx is the adjacent to that. So vx will be equal to v cosine alpha, and vy, that vertical component, will be v sine alpha. Where those are given in degrees, maybe they don't specifically mention, but we often use degrees in there. So let's write that shoot method and see what's going on there. So the shoot method is not going to return anything, I think, so it's just going to be shoot. I'm going to send in that alpha, and I'm going to send in the initial velocity. And yeah, I would feel better about that if they mentioned that was degrees there, but I bet it's degrees. Calling shoot computes initial x and y. Okay, so here I am calculating x, v in the x direction. is going to be equal to, now I'm going to be using, in the x direction, that's the cosine theta. So I'll be using math.cosine, and then I'm going to be needing to get that angle in there. Now, the cosine function, I happen to know the cosine function in Java uses radians by default. So if you want to use a value in degrees, if alpha is going to be in degrees, then we're going to have to convert it to radians. So I'll take the alpha value, convert it to radians, math.radians does that, and then I'll be able to pass it to that cosine function. So that gets me the cosine of the angle, and oh, I have to multiply it by v, the velocity that they've given me. So vx is going to be v cosine alpha. Gotcha. I think that'll work for me. And v sub y is going to be equal to v times math.sine of that math.radians alpha. And I think that's all I have to do. It's just computing that value there. So we'll have to check it out later on and see. Or I could run a real quick test right now, but we're in a little bit of a hurry here, so I'm gonna go ahead and see what else we can do here. A method move takes a delta sec. Oh, that's a time period, I guess, a change in time, delta sec, got it. That moves the ball to the next position based on calculations involving its current position and velocity and the amount of time that has passed. To do this, blah, 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 update, update. Oh, so this is what I was talking about over here. That's this. We're going to calculate those new x and y positions. And also there's a note here that we're going to be updating the y component of velocity. Okay, got it. So let's calculate x and y. Every time we call move, it's going to find a new position for those. Uh-oh, it looks like I've got some error messages here, so let me take a look and see what's going on there. Radians, maybe you meant 2 radians. Oh, of course I meant 2 radians. There we go. That's what I was missing. Thank goodness for my IDE helping me out. All right, let's do move. So we're going to move. We're not going to send anything back. We're just going to move. And I'm sending in a value, delta sec, which represents, again, that time period that's passing. That's that delta t over there in those equations. So using those equations, I guess in the x direction, the new x is going to be equal to whatever the x was before, plus the velocity in the x direction times delta sec. Let me double check and see that that's the formula there. X final equals x initial plus v in the x direction times that delta t, which I'm calling delta sec there. So good, this is going to work. I have x final and x initial to distinguish those, but here I'm just taking whatever was in there before and replacing that value with this new calculated value. Cool. And how do I get the new y position? Well, you remember that it's equal to the original y plus v in the y direction times delta sec plus 1/2, so I'll just say 0.5, times the acceleration, which is this g value. Oh, but it's a negative. Remember, it's down, so I'll say minus 1/2 g times delta sec squared. I'm just going to make it easy and say delta sec times delta sec. So y is going to be equal to y initial plus vit plus 1/2 at squared. Oh yes, okay, so that's working. That's going to work for me, I think. And then finally, they say down here, don't forget to update the y component of velocity. So the x component is going to just stay as it is, so I don't need to update that. It's just going to stay constant. But the v in the y direction is going to be equal to whatever the vy was before, plus acceleration times time, or minus g times that delta sec. That's going to get the new y value, and then next time I come around, I'll be able to do some more calculating there. So I think that's probably going to work for me. Yeah, that's pretty good. I haven't tried anything yet. I'm kind of walking on thin ice here, doing a bunch of programming and not really testing it. That's not good practice. Maybe I should just for a moment. Yeah, maybe I should just run in there and do a couple of tests and see if I can figure out what's going on. Have I completely blown it yet? Let me open up the Cannonball Tester and I'll just try a couple things here. So let me make a Cannonball. Cannonball, we'll just call it C. It's a new Cannonball, and I'm supposed to put in the X and Y positions. So I'll just put in 0 and 0. It's going to start in the corner. I start at the origin. And then what am I supposed to do? I'm supposed to launch that thing. So I'll give it some initial value here, c.launch, and maybe I'm going to give it a velocity of 10 meters per second. I'll just put the number in. And the angle, I'm going to launch it at 37 degrees. And I'm kind of curious there about what's going to be happening. Oh, it doesn't like that. Did I, what is it? What is it? It's not launch. Shoot. Sorry, it's shoot. Shoot. I'm kind of curious about what's going to happen there. So maybe what I'll do is I will, I don't really have any way of getting what's happening. I could call c.move and find out where it is, you know, a tenth of a second later. But that's not, I don't have any way of getting output out of this thing. If I try to run the Cannonball Tester, it's not really going to give me any output here. I'll just run the main. I'm not getting any output because I'm not printing anything. And I don't have any getters in my Cannonball to see what's going on. I could debug it. I could debug it and see what happens there. I could open that up, but let me just keep on with this assignment here rather than jumping into any debugging right now. I think I'm probably pretty good so far. I'm pretty happy with what I've done so far. And I think we're getting to the point here, this get location. Good. So we're going to write a method called get location. It's a method that's going to return the value point. We're going to get the current location of the cannonball rounded to integer coordinates. Now, I've never really used this whole point thing before, so certainly one of the things that we could do is we could say, let's take a look at the Java API on the point class and see what's going on there. So I'm just going to bring this up here. I'll do a find and look for the point class, and it's not that, not that. There's the point class. Let me click on that and take a look. So Java AWT point, it's got an X and a Y coordinate, the X and Y coordinate. And this is going to be great. This is awesome. So I can initialize the point with an X and Y value. That's awesome. So it looks like the whole idea with this point here is that I want to be able to get the location and return two values, the X and Y coordinates. And ordinarily, I can't do that. I can't send back two values. You can only send back one value. But if it's a point object, then it's a class that has those two values encapsulated in it. That's pretty sweet. So I think what I'm going to do then is write this method here. Let's go ahead and write this. This is the method public. It's going to return a point object, and get location returns the current location of the cannonball. Get location. So I'm going to return, I guess, just a new point object, and it's going to have X and Y in that object. I think I'm just going to send those back, and then I think I'm good. Doesn't like it. Doesn't like something here. Possible lossy conversion from double to int. Oh, that's right. So these are double values that I'm calculating with, but I'm supposed to be sending back something. I guess a point has integer coordinates there. So I need to make sure that I cast both of these. So I'll cast that one as an int. I'll cast this one as an int. And now maybe I'll be able to get away with that. Awesome. So let's do this. Here's the Cannonball Tester. Before we shoot it, I'm going to say system out print line, and I'm going to try and print out c dot get. So this is the cannonball, get location. And I'll just see what happens there as a result of that. All right. Very exciting here, what's going to happen. Oh, and this is great. So it's printing out what the object is. That's not really what I was interested in, but it is including in that the X and Y coordinates. So maybe I could break those out, but how about if I do this? What if I print the coordinates after it's moved? I want to see what's happened. I want to see what, this isn't how the whole program is going to run, but we'll see. Oh, and look at this. So it moved sideways, but it didn't move upwards. Oh, that's curious. I wonder why it didn't move upwards here, because, it did have oh, wait, did I shoot it? Yeah, I shot it, and it should have moved upwards. And then I said I'm going to move for a delta sec. I wonder, so now we're going to get into the debugging. I wonder why it didn't move in the Y direction. Let me try one more time and see what happens. I'm going to move it again, and then I will check its location again. Maybe something weird happened there. I'm not sure. Maybe you already know what the problem is. Let me go ahead and run this and see. Well, it's definitely moving in the X direction. Oh, and it moved up in the Y direction as well. Maybe for that first one, it didn't get a chance to move up very much. I mean, maybe it moved up like 0.4 and then that got rounded down to a 0. That's kind of interesting. Okay, well, maybe what I'd really like to do is watch this thing over time and see what happens. So how about if I do this? I'll say for int I equals 0. We'll just run it 10 times and see what happens. Less than 10, I plus plus. I'm just experimenting right now to see what's going on. So I've shot it, and now I'm going to, I guess I'll print out its original coordinates there. So system out print line, c.get location, and then I'm going to let it move, c.move. And what's my delta sec going to be? I'll just 0.1. Maybe I'll track it over half a second and see what happens there. And I'll do that 10 times. What do you think is going to happen as I run that 10 times? X, it's like cruise. Okay, so that was the initial. Now it's cruising across. Looks like it's cruising across pretty steadily here at 18, 36, 54. So it's going at 18 meters every half second as it cruises across. That's kind of cool. And here it's going up. Oh, wait, what? Now it's going down already? I'm not sure I like what's going on here. This doesn't seem like it should be falling down that quickly after I shot it into the air. I'm wondering if there's something wrong with my math radians there. That's kind of interesting to me, especially since this is supposed to be like 37 degrees in the air, right? Isn't that what I said? I was going to shoot at 37. Oh, wait, the angle's supposed to come first. They said the angle is supposed to come first, and I put it second. Well, that's a bummer. Alpha and then V. Alpha and then V. Oh, and then in my tester, no wonder I'm having issues here. Man, debugging's the worst. So here's my alpha, that 37 degrees, and here's my 10. I bet I get much better results now. Let's run it and see. Oh, so now we're cruising across 3.5, yeah, going at a constant like 3.5 or 4 meters per second, meters every second it's changing. And here I'm going up in the air. I went up in the air a tiny little bit, but then I started coming down again. Is that really working the way I thought it would? I thought it was going to go flying up in the air quite a bit more than that. What if let me try again. What if I change that angle, alpha and V? So I'm going to change this to like almost straight up in the air. I'm going to have it go up like 80 degrees. Oh, yeah, like 80 degrees in the air. That means it should really go up in the air. I should get lots of changes in my Y values here. Let's see what happens. And here we go. And so now I'm only changing about 1 meter a second. Here I'm going up in the air, 3, then 4, then 3, then back down. So that gravity just really kind of sucks it down unless I've got a more significant velocity. Maybe I need to put like a more serious velocity in here. What if I fired it up like at 30 meters per second? Maybe that would give me some some velocity up in the air. And if I take a look now, it's going up 13, 24, 33. And then it gets to some maximum 44, and then now it's starting to fall back down. Yeah, maybe this looks pretty good. These results seem a little bit more reasonable to me. I'd really like to graph all this stuff. If I graphed it, I'd be able to get a better idea of what was going on. Let me do one more thing in here. Since I'm just running this like 10 times randomly, I think what I want to do is, instead of just running 10 times, they said something about this, right? They said down here for the tester, identify initial position, create the cannonball, shoot, repeatedly call the move with a given delta sec, and repeatedly call get location, and stop tracking once it's landed on the ground again. All right, so that means I basically want to do all these things not in a for loop, but in a while loop. While, and I'm going to be checking c dot shoot. While c dot, or c dot location, I should say. While c dot get location, and remember that's a that get location has two values encoded in it. How do I just get the x location? Do you remember how we do that? How do I just get that x location? Can I do like, is there a get x or a get y or something? Oh yeah, get x and get y right there. So let me use that then. I'll get the location and I'll say while get location dot get y is greater than or equal to 0. As long as it's greater than or equal to 0, then I'm going to run through and do all this stuff. But once I've moved down below the ground, I'm not going to do this anymore. Maybe I'll just put a cute little crash note down here at the bottom to indicate that we've crashed into the ground. And what does this look like now when I run this? Oh, it's printing all those things here, and then it says crash. I think that's pretty good. I'm not a big fan of this Java AWT point thing, so rather than printing out the c.get location, how about if I dress that up a little bit more? System out print. The cannonball is at position. And then I'll just leave that there, and then I'm going to print out c.getLocation.getX, and I'll put a little comma in there, and then I'll also print out c.getLocation.getY. Yeah, see what that looks like. And maybe I'll even drop this down to like 0.2 of a second so I can get some really interesting stuff going on. All right. Run it, see what happens. I think we're getting super close here. Here's my cannonball. I'm firing my cannonball into the air. Where did my output go? Did I lose my output? There it is. Ooh, look at all that output. Pretty good. So I'm still printing out that thing at the beginning. I should probably get rid of that silly little thing there when I was just doing some error checking. Get rid of that. And position is 0, 0, 1, 2, 3, 4. So it's just trucking along right here very nicely. Here's the Y position going up in the air, then starting to fall back down, 43, 44, 44, starting to fall back down, and it's coming down, Here's the position, and finally it hits 0, and after that, boom. Must have hit a negative value there. So it landed 31 meters away from where it was launched into the air. This is awesome. This is great. Next step, I suppose, would be to put this into some sort of graphics format, and then we could watch the cannonball moving across the screen. But this is as far as this particular activity goes. I hope that helps.